Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Wassalatu wassalamu ala ashrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Allahumma la sahla illa ma ja'altahu sahla wa anta taj'al hazna idza shi'ta sahla. Okay guys, assalamualaikum warahmatullahi wabarakatuh. Good morning. Okay, all right. Okay. So how was everything? How was everything? Is it okay?
Alhamdulillah was great, doctor.
Alhamdulillah. Alhamdulillah. Osama, is it?
Yes, doctor.
Okay. Osama, where are you from?
Palestine.
Palestine. So you are in Palestine right now?
Yes.
Oh, okay. Right. So what time is now?
It's 3 a.m. 3/4.
Okay. Already subuh? Not yet?
No. It's still qiyam now. Inshallah.
Still. Okay. Inshallah.
Love to see you, doctor. Thank you very much.
Okay. Okay, let's start with the new lecture. Okay, with the new topic. So for today we are going to learn equilibrium 2D. Okay, equilibrium 2D. Okay, last time you have learned about resultant in 2D, and this time you will learn about the equilibrium 2D. Okay, this also regarding the rigid bodies. Okay, we have rigid bodies, and then you have to somehow analyze the rigid bodies, the forces, the moment, and so on. Okay, so for today, what you will learn. Number one is equilibrium condition when we have a 2D rigid body, reaction and action forces, the external and internal forces. Okay, and number two, you will learn about on how to draw FBD, free body diagram, with the desired FBD, with the desired body that you will draw later on. Okay, for 2D rigid bodies. Number three is regarding the analysis approach. Once you have the FBD, okay, you can analyze the rigid body. You can find the moment, you can find the forces, you can find the unknown. Okay, and the last one, we are going to learn about two force member. Okay. All right. There is the thing that you have already learned before. Okay. So we do have a particles and also a rigid body. Okay. A particle, when the particle is in equilibrium, so all forces must be equal to 0. So all x and y component should be 0. Okay, this follow Newton's first law. Okay, and then same goes to rigid body. We do have additional, which is moment. Okay, moment. Okay, since rigid body can be rotated, okay, we have to include the moment equilibrium system as well. Okay, just recap back the equilibrium equation there, the Newton first law. Okay, about the procedure for drawing FBD. Okay, so basically, if you want to solve the problem, the first thing that you have to do is draw the FBD, a free body diagram. So how to draw? Is it? This is very simple. Okay, how to draw? The first one, draw the boundary of the chosen section and detach or separate it from all other bodies. Okay, I draw a very simple example, very simple rigid body like this. Okay, a box. I have two boxes, for example, connected with a cable. Okay, and then I have let's say the box on the floor. like this, for example. Okay, and the box, the right box attached with another cable, which is exerted with a one pressure, one force, like that, for example. Okay, and I put a mesh 1, mesh 2. Okay, so let's say the first step that you have to do, let's say we want to analyze the second box. Okay, we want to draw FBD for the second box, which is M2. So the first thing that you have to follow is the first statement there. Draw the boundary of the chosen section and detach or separate it from all other bodies. So let's say we are choosing box number 2 here. So you have to separate it from the overall system. So you have to take only a single body like this, which is M2. Okay, you have to detach like this. Okay, because I'm choosing the box number 2. Okay, this is number 1. And number 2, for body with mass, put the weight equal to mg acting at the center of gravity g of the body in the vertically downwards direction. So basically, for the second statement there, it is straightforward. You have to put mg here, which is weight. Okay, done. And then the step number 3 is input all external forces acting on the body. Okay, since the body attached to the another box with a cable there, this cable, okay, we have to put the external force here, okay, which is I put it T, okay, and then another external force is of course P here. Okay, so for a system involving cable, the force of the cable must be at outwards of the body. Yes, like this. Okay, this is the tension coming from the cable. Okay, the cable must be tension. Okay, number 3 is done. And then since the box that I draw just now is on the floor, okay, it's on the floor, so meaning that there is some reaction, for example, reaction of friction, okay, friction at this part, okay, at this part. So put the reaction where the body touches or connected to a different rigid body. Okay, so let's say this board is not connected to the other rigid body, but it is touch the surface, the floor. Okay, so we have to put reaction. For example, I assume the reaction or the friction is on this way, like this, for example. I put it R, for example. Okay, this is done. And of course, the FBD should also include dimension for the process of taking moment. Okay, you have to put dimension. In this example that I show you, there is no dimension. Okay, because it is a simple box there. Okay, if let's say we have the rigid body like this, for example. Okay, so you have to put the dimension for each part to 2 meter, for example. This one 1.5 meter, because later on you will calculate the moment. Okay, so you have to put dimension like this. Okay, so done. This is overview on how to draw FBD. Okay, so before we draw, before we can go through or go more detail about the FBD, let's take a look at the reaction. Okay, so 2D we do have reaction. In real life, in a real situation, we do have reaction as well. When a car moving from one point to another point, okay, the reaction occurs at the tire. Okay, the reaction occur at the tire. Same goes to other application. Okay, so this is the simple body, the simple body. We have to start with the simple body to understand where is the reaction occur. Okay, we do have rollers or rollers. You have rollers, rockers, and frictionless surface. Okay, 3 types of condition. Okay, so rollers. So if you look at this, okay, we do have a rigid body that connected with some pin there with another rigid body, and then at the bottom part, which is touches the surface, have some ball or rollers there. So if you found this system, we can assume that this is the rollers type. Okay, same goes to this one. Okay, this is straightforward. We do have wheel, for example, wheel there. Okay, attached with the another rigid body here, and the wheel is connected, is touched, it touches the surface. Okay, so these two condition, okay, we consider rollers. Okay, how about rockers? Rockers, when there is no where there is no circle shape, like this one. This one is circle shape. This one is circle. Okay, but rockers, the shape that touch the surface is not in circle shape. So this is what we call it rockers. Okay, so same goes to the rollers. They can move easily on the surface. Okay, and last one, without any rollers or rockers, there is only a single rigid body there. Okay, so it is also touch the surface, but without frictionless. Okay, without friction. So if you find this system, okay, there is some reaction that occurs at the surface. Okay, there is some reaction that occurs at the surface, and the reaction is only one, which is pointing to the rigid body, which is pointing to rigid body like this. Okay, and this is the surface. Okay, so it should be 90 degree to the surface. Okay, 90 degree to the surface and towards the body, pointing the body. Okay, so to make this understand, basically I'm not suggest you to remember this thing. I suggest you to understand. Okay, not to remember but to understand on how to determine this reaction. Okay, basically if you can understand this one, you can straight away know that this system only have one reaction. So in order to understand why we have a one reaction, you have to determine D or F. Okay, we have to determine D or F, degree of freedom. Degree of freedom. So basically, what is degree of freedom? Anyone? Anyone? What is degree of freedom? Degree of freedom. Anyone can answer it?
Is it error plus
Sorry?
minus error?
No, it is not error. What is freedom actually? Freedom.
Free to differ, free
Free what?
for variation. Free for variation.
Sorry, cannot hear you. Free?
Free for variations.
Free from variation?
Free for variations.
Okay, okay. Can you make it specific? What free? What is the definition of freedom? So, anyone? Anyone? What is definition of freedom? Freedom. 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 No one. Akila, Hanani, are you still with me? Are you with me? Freedom, friction equal to 0, no. Free from connecting the surface. No, depend on the how many movement direction. Yes, yes. Same Biki. Yeah. Yeah, freedom. Yeah. Freedom is free to move. Okay. So you are now freedom to go anywhere. Um, except crossing the state. In Malaysia lah, in Malaysia. You can go to Sergamat, Keluang if you stay in Johor lah. Okay. So it is freedom. You can go everywhere. So same goes to this system, freedom. How many direction, direction, okay, the system can move. The system can move. So let's say the first system here. The first system here. So how many direction this system can be moved? Let's say I put this as this. Okay. For the first system, how many direction? Anyone? How many
In
direction?
one plane, 2 directions. In all the planes, 8 or 360. It's free to move anywhere.
No, we only consider 2D. We only consider 2D.
Then 2 directions, either left or right.
Sorry, which part? Left and right? Asan, is it?
Yes.
Which direction? Right and left?
Yeah, left and right. 2
Like
directions
this.
only.
Oops. Like this. This is what you mean.
No, rotation, like rotation.
Yeah, rotation. But maybe I have to do like this lah, to avoid confusing. Okay. I only consider this rigid body in the system because it is touch the surface. Okay. So I make it the purple color. Please exclude the other body, which is this one. Exclude this one.
Okay.
Okay. So for the purple color, how many D or F?
2.
No. Guys, everyone, please think about it. How many D or F direction of movement the system can be go? How many? How many? The answer is 3 actually. The answer is 3. Do you know why 3? Where is another direction? Wong King Tong Z. Well, D is to D. D is to D. No Z exists. There is no Z exists. This one is 2D. So this one is correct. This one is correct. This one is correct. This 2 is correct. Where is another direction where the body can be moved? Yeah, same big key. Upward, like this. Okay. So for this system, the DOF is 3. Okay. So the purple color cannot go down. Okay. This one cannot go down because we do have this surface. Because we do have this surface. You can lift up the purple body. You can move left and right. Okay. But you cannot push the purple rigid body downward. Okay. Because we do have this surface. Okay. Because of no DOF, meaning that we do have reaction there. We do have reaction, and the reaction that oppose this purple color to be moved downward, okay, is coming from the surface. Okay, the surface. So that's why the reaction is like this. Okay, to oppose back the downward action. Okay, do you get? Do you get the idea? Guys, do you get the idea?
Can you repeat why it can't be downward?
Okay. Okay, so before for me, I'm not memorize the reaction on the system. I have to understand the system. So basically, this system, okay, having this body, okay, this body, okay. So we do have let's say I put it like this direction, the axis in this direction. So if you can think, you can imagine the movement. Okay, all right. So there are 4 possibility of movement. Okay, left, right, upward, and downward. Okay, 4 possibilities. Okay, if you think about this one, okay, if you imagine this one, okay, you can know that this rigid body can move up like this. Okay, can go right like this. Okay, can go left like this. Okay, but this system, this rigid body cannot go down. Okay, because we do have this surface, this surface. Okay, do you get at the moment?
Yes. Thank you.
Okay, so meaning that DOF for this system is equal to 3. This one left can be go, up can be go, and right can be go, but downward cannot. Okay, so DOF is equal to 3. So where the direction cannot go, meaning that there is a reaction opposed to the rigid body. Okay, so if this direction cannot go, then we can assume that this direction have a reaction. Okay, so that's why we put a reaction this way, to oppose, to stop the movement of the rigid body, to stop the movement of rigid body. Okay, do you get it?
Yes, doctor.
Okay, so to everyone, do you get it?
Yes, doctor.
Okay, great. So same goes to other system on the slide. Okay, like this. We only consider the wheel. Okay, the wheel that attach or touch the surface. The wheel can go up. The wheel can go left. The wheel can go, right, left. Okay, but the wheel, this wheel cannot go down because we have this surface. Okay, cannot go down. So since the wheel cannot go down, meaning that there is a reaction that stop the movement. So which is like this. Same goes to this one. Can go right, left, and up, but cannot go down. Okay, and same goes to this system, the final one. Okay, this rigid body. Oops. This rigid body, okay, can go right, can go left, can go up, but cannot go down. So that's why we do have only one reaction that oppose, that stop the movement of the rigid body. Okay, so move to the next one. All right, this is the another system. Okay, a force with a known line of action. Some system we call it collar or frictionless rod or frictionless slot. Okay, collar on frictionless, oops, on a frictionless rod or frictionless slot like this. Okay, so basically we can consider one single body. Basically in the system, okay, in the system we do have 1, 2, and 3 rigid body. Same goes to this one. 1, 2, and 3. Okay, but in order to make it simplify, we choose the point or the touching surface between the rod and the other body. Okay, the rod, this rod, and other body. Okay, so all right, so basically if you found this system, okay, we can know that this system also have 4 possibilities of movement. 4 possibilities of movement. Okay, this is the 4 possibilities. Okay, all right. And then for this system, we are choosing the center one. Okay, this one. Okay, and we have to determine the DOF first. DOF first, right? So how many DOF for the purple color?
All 4 directions.
Huh? All 4 direction?
No, sorry, 2.
No, the answer is wrong. How many do I have for this system? For the purple color? How many movement? Yes, 2.
Only 1. Oh,
2. Okay, 2. Which one of 2? Is it right, left, top, down? Yes, up and down. Okay, this purple color. Okay, this purple color can be moved up like this and down like this. Okay? But it cannot go right and left because we have the rod there. Okay, we have the rod there, this rod that fits the position of purple body. Okay, so meaning that we do have 2 DOF. degree of freedom, can go up and down, but cannot go left and right. Okay, so if the movement cannot be sorry, if the body cannot be moved, okay, in that direction, meaning that that direction having reaction. Okay, this direction, x direction having reaction, x direction having reaction, because to stop the body to move. Okay, so in order to do that, so we can draw a simple rigid body like this. Okay, and the reaction should be this way. Okay, this way. Okay, so bear in mind that this one is closed system, which is the touching surface is on two sides. Okay, so you only can consider one direction. Okay, either one. You cannot put two direction like this. Okay, you only have to put one single direction either way, not both. Not both. Okay, because if you put both, meaning that you cancel each other. And same goes to the other system on the right side. Okay, I put the wheel in the purple color like that. So the wheel can go up and go down, okay, like this until here, and go down like this until here, but cannot go right, cannot go left. Okay, so the direction that cannot be moved, we consider reaction. Okay, any question? So far, any question?
Doctor, DOF, it's just work with this kind of parts like this, or with everything?
Can you repeat, please?
DOF, degree of movement of force. It happens with everything, or just this type, the slot, or the color?
Everything meaning that every single body?
Yes, doctor.
Okay, so this system, there are three rigid body. Okay, but the example only show the example for this one, which is the collar. Okay, the collar, this one. Okay, only collar. If you choosing the other rigid body, for example this one, the DOF will be different. Okay, DOF will be different.
Okay, doctor, clear.
Okay.
Yes, doctor.
So if we want to know about DOF for the other part lah, we can discuss right now. Okay, let's say I'm choosing this one. Okay, I'm choosing this one, this rigid body. So how many DOF for this system?
Two?
No, there is only one. Okay, there is only one, which is a moment, a rotation. Only one. Because this one, this cannot go left, cannot go right, cannot go up, cannot go down. Okay, okay, because it is attached with the collar. One. So the thing that can be moved for the rigid body, this third rigid body, is only rotation. It's only rotation. Okay. Same goes to this one. Only movement, only moment, only rotation is the DOF. Okay.
Okay, doctor, thank you. Now I understand.
Okay, great. So right now we only have to consider this system, which is the second rigid body, the collar. Okay, not the third one. Okay, the other one. The two forces component involve two unknowns, meaning that in this system we do have two unknowns. Okay. The previous one we do have only one single unknown like this. One single unknown. This one is also one single unknown because we can only choose one way. Okay, cannot both. And but this time we do have two unknowns. Okay. Why two unknowns? This is the condition. Okay, why two unknown? Okay, this is the condition. The first condition is frictionless spin. Okay, and the second condition is the rough surface. Okay. Osam, can you mute your mic?
Doctor, this is not mine. It's for Adriana.
Oh, Adriana, can you mute your mic? Adriana? Ya, ada orang tak apa. Testing. Testing. Adriana, if you are with me, please mute your mic. Okay, thank you. Okay, two force component involving two unknowns. Okay, the first one is frictional spin, and the second one is rough surface. Okay, so frictional spin, we do have pin there. We do have pin there. Okay. Oops. Yeah. This one. Okay, this rigid body attached with the pin system. Okay, which is this. Okay. So my question is, how many DOF involved with this system, with this purple rigid body?
Well,
Yes, the answer is correct. And the one is which direction?
moment, rotation like moment.
Yes, correct. I already showed you just now, the previous slide. So this is the thing that the system can be moved, moment. Okay. The system, this one, the purple color, okay, cannot go up, cannot go left, cannot go down, cannot go right. Okay. So the purple rigid body only can be rotating. Only can be rotating. Okay. Since DOF only one, okay, which is moment, meaning that all direction of X and Y have reaction. Have reaction. Okay. All right. So I assume this one follow this axis. Okay. So if I draw the rigid body, it should be reaction like this lah. Let's say I put R Y R X. Okay. This example show you the axis is like this. Okay, it is depend on your assumption of the axis direction. Okay, so since this one we do have, since this system only have one DOF, meaning that the other direction X and Y having reaction and give two unknowns. Okay, same goes to the rough surface. Okay, the previous one, it is frictionless surface. There is no friction. The surface is very smooth. Okay, it's very smooth. Okay, but this time around the surface is rough, meaning that the surface having friction. The interface between the surface and the body having friction. Okay, so same goes to this rough surface. If you have this rigid body, okay, you can only rotate this rigid body like this. Okay, right? So you cannot go right because having the friction. You cannot go left because having the friction. Okay, you cannot go down because having the surface. Okay, and the thing that you must aware about this system, you can bring this body upward like this. Okay, do you agree with me? Do you understand? Guys, do you understand about this one? Rough surface?
Yes, doctor.
Okay, so since we cannot do this one, we cannot do this one, we cannot do this one, meaning that, okay, in this direction x and y, we do have the reaction. Okay, same goes to this one. It should be only consider one direction, one single. You cannot put two ways like this. Okay, you cannot put two ways like this. Okay, you have to put one single direction. Okay, one single direction. Okay, so basically we cannot go up, cannot go down. So we do have reaction here, R, Y, for example. We cannot go left, we cannot go right. So there is another reaction as is, which is this one, for example. Okay, RX. Okay, and these two unknowns should be 90 degree. The first one should be 90 degree to the surface, toward the body. Okay, this is the surface and this is 90 degree angle. Okay, 90 angle between the surface and the reaction Y. Okay. Okay, it can be either upwards or downward in decline. Upwards or downward the incline. As I mentioned just now, for the RX, for the X component, okay, since we cannot move two direction, left and right. Okay, you only can put either one. Okay, left or right. Okay, you cannot put both. You cannot put both. So you have to put either upward. Upward meaning that left for the system. Okay, this one. And downward, oops. Downwards meaning that this way. Okay, you have to put either one. Okay, so far so good. Any question? Any question?
No, doctor.
Okay, if no, I proceed to the next one. Okay. If you found this system, you will get three unknowns. Okay. You will get three unknowns. Three unknowns. Okay. Why three unknowns? Where the rigid body is fixed or welded support. Okay. So let's say this one is the wall, for example, a wall. And this is the rigid body that fits permanently in the wall. Okay. Permanently, not touching, but permanently fixed like this. Okay, fixed inside the wall. Okay, it is different like this. This one is different. If the system only touch the wall, it is only involved with 2 unknown. But if the rigid body fixed or inside the wall, okay, it will be involving 3 unknowns lah. Okay, 3 unknowns. Okay, so for this system, how many DOF? How many DOF?
One.
No.
0 because it's fixed to the wall.
Yes, yes. DOF is 0. The rigid body cannot be moved at all. Okay, it will fix forever and ever there until the end of the world. Okay, static and static. We are talking about static. In real life, we can move that rigid body lah by having external force. Okay, but in static condition, the rigid body will be forever and ever on the wall. Okay, so that DOF, degree of freedom, equal to 0. Okay, so there are possibility of movement, okay, like this, but since DOF is 0, so meaning that all direction, all rotation having reaction. Okay, so we do have a reaction here, here, and moment lah, like this. Okay, like this. Okay, and the direction of moment is depend on you. Okay, the one that I draw is clockwise. The one that shown in example is counterclockwise. It is depend on you. In the end of the day, the answer will be same. Okay, same goes to the direction. This one, you can put it like this. You can put this way. My direction from the point, not onto the point. Okay, easy, right? Okay, this is an example. If you draw FBD for the human skeleton, human body, okay, like this, ground reaction force, because this foot cannot go down. This foot cannot go down. That's why we have ground reaction force, GRF. This foot can go right, left. Sorry, it cannot go right and left because we do have friction, rough surface there. So this one cannot as well, this one cannot as well. Okay, the foot only can go up. For example, I select the foot. Okay, and the body weight must be center of the body. Okay, there is an example. Another example is more specific on the inside of the human body. Okay, you can see the ground reaction force that acting perpendicular to the surface. Okay, and then we do have a force acting at the Achilles tendon. Okay, and there is another example in 2D. Okay, where there is dimension, a lot of dimension, okay, with a lot of point there, from a complex geometry of the human hand, you can make it simplify like this. Okay, you can make it like this. It's very simple diagram like this in order to solve the problem. Okay, later on you will go through this one during the exercise maybe. Okay, I will give you some example of the human body. Okay, right. Okay, this is example. This is example. Okay, the example on how to draw FBD. The first thing is draw the FBD for the mechanism shown. So if the question asking you a very general FBD, general without any specific like A, B, B, C, D, so you have to draw all system, excluding the external factors, external reaction, external bodies. Okay, so in the example, where is the external body? Which one is the external bodies? Yeah, Wong Kim Tong, yes. This one is the external body. Another two, where is it?
The circle.
Huh?
This circle. D.
No.
A and C.
No. Wall, yes, wall. Lin Kai Yi, the wall itself. This one is external. We're not considering in the system. Another one. A wall juga lah, wall. Is it wall as well? This wall lah, floor of wall. Okay, you have to exclude this thing in your FBD. Okay, you have to remove it. Okay, you will have to remove this external body in your FBD. Yes.
The mass didn't affect the system.
Sorry?
The mass.
The mass
didn't
will
affect the system.
Yes, the mass will affect the system, but the body should be removed from the system. Okay, we just put the weight like this on the system. Okay, the body itself should be moved from the FBD.
Okay, doctor.
Right. So if you have this one, you can draw it. You can identify the reaction. Okay, the reaction. Okay. So how many reaction for this mechanism? Can someone tell me? How many reaction acting on this mechanism? How many reaction?
Doctor, in
Yeah.
D, there's a moment in
No,
D.
no, because you're not excluding the D. You cannot put the reaction there. The one that you have to put reaction is the location or the position that you remove the external bodies.
At point A, upwards.
Okay. Point A, upwards only. Point A. Okay, we look at the point A first. How many reaction occurs at this point A? How many reaction? It is spin mechanism.
So one moment.
No. Pin, the previous one that I show you. This one. How many?
Upward and downward. Two. Upward and downward.
Did you say about the reaction or the direction?
The direction, upward and downward.
How and downward direction? What purpose of this direction actually? Okay lah. I explain to you lah because maybe this is new for you. Okay, so if you consider point A here, okay, you have to imagine how many, you have to calculate, you have to find out the DOE first. Okay, the DOE first. Okay, this is the pin system. The pin system. So for this DOE, already answered there. For this DOE, how many do DOF? How many do you have, guys? I'm asking you about DOF. How many DOF? Yeah, the answer is 1. Okay, this system can be only rotating, but this pin cannot go up, cannot go left or right. Okay, cannot go left, cannot go down. Okay, cannot. So the straighted direction having the reaction. Okay, so the rotation is allowable for this system at A. So meaning that there is no reaction at all for the rotation. Okay, all right. So that's why the answer is 2 reaction, correct? That's why we do have 2 reaction at this point, okay, which is X and Y direction. Okay, let's say A, Y, and A, X. Okay, how about at point C? How many reaction there? At point C,
Upward and downward. 2 upward and downward.
is it reaction?
It move upward and downward, isn't?
So you are talking about movement, right?
Yes, doctor.
So this system can be moved up and down, is it?
Yes.
How about right and left? How about movement? This one.
The wall, it stop it. The wall. 2
Yeah,
was there.
yeah, but only one single direction, is it?
Yes.
Okay. So how about right? Is this system can go right? This point can go right? Can or not?
No, because of wall. Other wall. Point A.
Okay, the answer is actually yes, can. Right can. The thing that cannot is left because of the wall. This one cannot. This one cannot because of the wall. Okay, because of the wall. So because of this one cannot be moved in this direction. So meaning that we do have one reaction. So moment also can occur. Okay, this one can move as well. So there is no restriction on the rotation. Okay, so basically if the movement can be the system can be moved in that direction, meaning that direction having reaction. Okay, and the reaction should be opposed and should be pointing on the point on the body. Okay, so this is your final FBD as shown and in this slide. Okay, this is the what do you call it, FBD, and don't forget to put week lah, week. Okay, so how about the second one? The second question, draw FBD for a member of a member AB. Okay, what is the first step that you have to do? Alia, what is the first step that we should do, Alia? Alia? Are you with me, Alia? Intent no Faiza, what is the first step we should do before we can identify the external force, the internal forces? Intent. Ada tak ada ni? Respon lah.
Identify the force members.
Yeah. But I'm asking Intan right now. Intan, are you with me? Are you still in the class?
Oh, doctor, sorry, I didn't focus with you. Sorry, doctor.
It's okay. Intan, ada ke tak ada ni dalam kelas ni? Kalau ada cakap ada. Tak join kelas ke? Ada ke tak ada? Intan. Muhammad Ikmal.
Yes, Doctor.
Okay, nasib baik ada. Mana dia orang ni? Join kelas ke tak kelas? Join ke tak?
Saya pun tak tahu, Doctor.
Tak tahu. Okay. Okay, Ikmal. What is the first step that we have to do if we are looking at member AB?
We focus mechanism at A and B. Isolate
Okay.
them from other.
Okay, so meaning that we have to draw AB saja, right?
Yes, Doctor.
Okay, good. Okay, you have to draw the AB only. Okay, AB like this. Okay. So next one. What is the second step? Not Ikmal. I will go. I will select a name. Nai Cheng Kan. Are you with me? Nai. How to pronounce your name actually? Kan. Are you with me? Tak join juga kelas. Okay, Nik Muhammad Azri.
Yes, Doctor.
Okay, good. So what is the next step after you draw AB member?
Remove other rigid body.
I already removed there. Actually, we only consider AB member. So what is the next step?
What we call it?
Nak kena baca balik.
Reaction.
Yes, reaction. You have to determine a reaction. Okay, so how many reaction? Let's say I'm choosing B, point B. How many reaction at B? How many reaction at B? Okay, maybe someone can help him. Okay, how many point at B? How many reaction at B? Okay, 2 reaction. Yes. Which direction? Which direction? The answer is 2. At B, we do have 2 reaction at B. X and Y axis, yes, correct. So the reaction at B, we do have 2. Okay. BY and BX. Okay. Because B is the pin system. So you can, understand that pin system only can be rotating. Okay. Can be only rotating. They cannot go up, cannot go left, cannot go right, okay, cannot go down. Okay. So if you have the pin system only can be rotating, which is the DOF only one. Okay, the rest is restriction. Okay, how about point A? How many reactions there? Point A. How many reaction? Nur Aisyah Nabila. Ada tak ni?
Yes, Doctor.
Sebaik ada. Mana kawan-kawan awak ni tak join kelas saya?
Sorry, Doctor. Yang for point A, one reaction
No.
x-axis.
No.
Eh.
Okay, tak apa. It's okay. This is learning process. So point A also have 2. Okay, it is a pin system. Okay, pin system. Okay, 2 as well. EX, AY. Okay, let me repeat about the point, about the pin system. Okay, if you have pin like this, okay, pin like this, let me repeat. Okay, so you can determine the DOF. Okay, DOF for the pin is only 1. Okay, 1, which is the moment. Okay, which is the moment. The system can, the rigid body can be moved only. Sorry, can be rotate only. Okay, but this rigid body cannot go up, cannot go right, cannot go left, cannot go down. Okay, so meaning that we do have 2 restriction, 2 direction. Okay, in 2 direction. Okay, so that's why E is AY and AX reaction only. Okay. Okay, yes, Tan Wee Kang. The F for A is 1, which is moment. Yes, correct. Okay, how about others? Is there any point that we have to put reaction or action or anything or force?
In the middle of AB for M.
Sorry?
W. In the middle of
yes.
AB.
W. Yes, W here. Okay. This one is not completed yet. We do have another reaction. And where is it? Yes, at D, Siti Nur Shuhaila. Roller at D. So which direction? Okay, if you look at this rigid body, okay, you have a touching surface here that touch the roller, the wheel, the roller. Okay, so at this point, how many reaction and where is direction? Sing Bikin point towards rigid body. Is it rigid body A, B? Okay, great. Okay, it should be like this. And I put it D lah. Okay, it should be like this, D. Okay, so why only single direction? Why only single? As I mentioned, don't memorize, but you have to understand why only single. No, not mass. Why this single? Okay, maybe I draw a wheel. Okay, and this surface. Okay, let me explain. If you consider this rigid body and D, okay, I draw it in purple color. Okay, so this AB member, if you connect with D, and you have to identify the movement of AB member. Okay, the possibility is here. Okay, I think I have to draw it in at the center. Let me draw it again. Okay, this one at the center. Okay, for this rigid body, AB relative to the D, if I move forward, I move upward, it can be done or not. My question is, if I push the AB upward, it can be done or not? It can be moved or not?
Yes. Yes, I think.
Yes. Ya, benar. If you consider this one as the restriction, this purple color only, I draw the purple color of the rigid body. Okay. So if AB member can be moved up? Yes, the answer is cannot. This AB member cannot go up because of this restriction. Okay, it will be collapsed later on. Itu. You cannot go up. This one cannot. So if cannot, meaning that we do have reaction at point here lah. Of course, at the touching surface. Okay, alright. If I move AB member to the right side, it can be moved or not? My question, it can be moved or not?
No.
To the right. Sorry?
No.
No. Why no? Why cannot?
A is pinned there.
No, I just considering the purple rigid body. The purple rigid body. It exclude the A, exclude the B pin.
Oh, okay. Yeah, it can be done.
Okay,
Okay.
great. Meaning that you understand it. So if you include the A pin, meaning that it cannot be moved lah. But in this example, in this explanation, I only consider two rigid body, which is the purple color. Okay, the roller and also the AB member without having any pins, without any having the wall. Okay, and so on. Okay, so the AB member can go right. How about left? Left can or not? Yes, can. Yeah. Oops. How about downward? Excluding the pin system, How about downward? Yes. Okay. How about rotation? Rotation? Can or not? Hassan. No. The answer is yes. You can rotate this AB member. Okay. Because there is no restriction at all. You can rotate like that. This is the AB member. Yeah. This is a roller lah, roller. My coin there, if you can see my camera, this is a coin. My coin is the roller. My pen is the AB member. You can rotate like this, right? Left, you can move left, right like this. You can bring downward like this, but you cannot go upward because of the restriction from the coin. Okay, the rotation can be moved like this. The rotation can be happen like this. Okay, do you understand? Do you understand the explanation? Yeah. Okay, so the cannot one, the cannot one, I call it cannot one, only one. So meaning that there is only one reaction. So that's why we put this one. And the reaction should be towards or pointing the rigid body of AB. Okay, so this is your DOE. Sorry, FBD. FBD for member AB. Okay, all right. Are you clear? Do you clear any questions so far before I proceed to the next one? Any question? No, right? Easy, right? It is easy lah. Easiest subject in the world. Static is easiest subject. No need to worry too much. Okay, you can score A actually. Okay, let's move to the next one, which is draw a FBD of a member B, C, D. Okay, B, C, D. Okay, again, my question, what is the first step that we have to do? Yeah, draw BCD only. You have to draw BCD only. BCD, BCD, this one only, excluding all body, roller, BE, pin at E, the mesh, the object for the mesh. Okay. Okay, this one exclude. This one exclude. This one is also excluded. Okay. So you only have to draw BCD. Draw BCD like this. And put the BCD point. Okay, what is the next step? What is the next step, folks?
And identify forces and reactions.
All right. Alia said that, Doctor, do we draw the roller of D2? Yes. Actually, you can draw it as well. You can draw it as well. So if you want to draw, then okay, never mind. You can draw it as well. Okay. Okay. So what is the next step? Again, who said just now? Usam,
Yeah, hi, Doctor. Yes, me.
Okay. What is the next
force
step?
and reaction.
Okay. Yes.
Forces and reaction.
Yes. Which? Okay. Let's say we are choosing point B first. How many reaction there? At B point, it is similar like before. Okay, it is similar like before. Okay, it is a pin system. So meaning that we do have two reaction, BY and BX. Okay, how about point C? Point C, how many reaction there? No, the answer is 1. The answer is 1. Okay. The answer is 1, which is this way. C. Okay. You can put C, or maybe you can put CS. Okay. Because C is equal to CS in this system, because we do have only one reaction at C. Okay. Do you know why? Do you need me to explain? Should I need explain? Should I need to explain? Okay, Alia said yes. It is same goes to the previous one. Okay. Okay, let me erase this thing. Okay. So if you look at the point C, you have to draw the body, of course, and the wall to identify the reaction. Okay. All right. Okay, and then you have to determine the D or F lah. There are in this case there are 5 possibilities: up, down, right, left, and the moment and the rotation. Okay. So if about rotation, is this BCD can be rotated? Okay, let me proceed. Let me do quickly. This one, rotation can be done. Okay, up can be done, down can be go, right can be go. The only thing that cannot go is left. Okay, left. The system BCD cannot go left because of the wall. Okay, so meaning that we do have 1, 2, 3, 4 D or F, and the only thing that cannot be moved is in in the left direction. Okay, so if you have this one, meaning that this direction having reaction lah. So reaction we put C like this. Okay. Any question? No, right? Okay. Okay, same goes to this one is also the same. Yeah, already done for this one. AB, yes. Member AB only. Okay, this is the FBD. Okay, and this is the BCD. Okay, yes, same. Yeah, and the point here, I forgot to mention here. Point here. Okay, point here. Since we do have, let me erase this thing. Again, since we do have this roller, and we considering this restriction, okay, this restriction. So this roller can go right, okay. Sorry. This restriction, this roller can go right, can go up, can go left, can rotate, but downward cannot. Okay, if cannot, meaning that we do have reaction, which is D lah. Okay, there is the way on how to draw FBD with the reaction. No need to memorize, but you have to understand. Okay, no need to memorize, but you have to understand. Okay, same goes happen to this slide. Okay, so far so good. Can we continue to the next example? Can we?
Yes, doctor.
Okay, or maybe you want to end the class because, yeah. Can or not? We continue with the next example.
Can doctor?
Okay, okay lah, okay lah. You know what? The online class is very boring for me lah, because I cannot see your faces, I cannot see your your condition there. I cannot get a proper response from the student. Okay, because in the class we have to have two ways communication. Okay, the lecturer should give the lecture, the lecturer should ask the question from the student, and the student should reply back the question. Okay, that's why I try to do synchronized method instead of asynchronous. So meaning that I have a feel to teach student like a normal class, physical normal class. Okay, let's move to the example 2. Okay, same goes to the previous one, only draw the FBD. This one is only drawing, not considering, not yet covering about the calculation. Okay, the FBD first. So you have to make sure that you can draw FBD very good, very accurately. Okay, if your FBD is wrong, your calculation will be wrong. Okay, if your FBD is right, maybe inshallah your calculation will be right as well. So FBD is important. It is not only in the static, but it will be important in your next course, which is solid mechanic. Okay, FBD is really important. So make sure that you are able to draw the FBD correctly. Okay. All right, example 2. Draw the FBD for the mechanism shown. Okay, what we should do first? Guys, respond please. Tak ada jawapan. What we should do first?
Select any one point about which we have to draw FB.
Select one point. Okay, the first thing that you have to do is you have to only consider the mechanism, the total, the overall system. Okay, excluding the external body like the wall there. Okay, this one. You have to exclude from the system. Okay, and then you will keep the overall system only in your FBD. Okay, all right. So let's say I just remove this one from the system. Okay, okay, all right. So next one is the determination of the reaction. So at point D, how many reaction there? Let me do quickly. At D point, we do have two reaction, dx and dy. At F point, we do have two reaction as well. Okay, fx and fy. Okay, and at here, okay, we do have a tension. Okay, that's it. That's it. Very easy. If you consider the overall system, the overall mechanism. Okay. If you let me erase all the thing. Okay, the second one is draw the FBD of member BCD. Okay, you have to consider BCD only. BCD, this one. Okay, and then the first thing that you have to do is draw that member only, like this. Okay, and then put the point. Point B, point C, okay. This is point, or maybe I can put it point A, B, C, D, E, F, G. G lah, G ada, H lah. I put point H, okay, and D. Okay. So for this B, C, D member, you have to determine the reaction as well. Okay. So for point B, how many reaction? Point B. The answer is 1. Point B, one reaction because it is
Moment.
roller. No, moment. This one can be moved actually. Can be rotate. Okay. This is only thing, the only reaction that we have. Okay. And this one, if you consider this rigid body BC, okay, related with this beam, for example, this BC can be rotate, can go up, can go down, can go right. Okay, this one can go up, can go down, right, and can rotate, but cannot go left. Okay. Okay, B. At C is a pin. Pin meaning that we do have two reaction. Okay. At H is the tension cable. It is a cable. Just put a T there. And at D also pin. Okay. All right. Do you get any question? Any question, guys?
Clear.
Clear. Okay. So let's move to the next one. Let me erase this thing. Okay, the next one, the third one. Draw the FBD of member ACEF. ACEF, ACEF, ACEF. So you have to draw, you have to consider this ACEF. ACEF. Okay. Exclude all the bodies. Okay, you draw it like this. Only. ACEF and put the point lah. A, C, E, and F, E, F, ACEF. Okay. So again, you have to determine the reaction every single point. So point A, since that one is pin, we can know that the reaction are 2. Okay. C also pinpoint CX, CY. Okay, E, how many reaction at E? How many reaction at E? Yeah.
1, doctor.
No, the answer is 2. But thank you for the response. Okay, the answer is 2. Never mind. This learning process. Okay, don't be shy because the wrong answer. Okay, the 2, there are 2. Okay, because this one is pulley and cable lah. Yeah, pulley and cable. So there are 2 reaction. We put T and T there. Okay, and another one F, which is only roller there. Same goes to B just now. Okay, only single reaction. Okay, oops. Okay, this roller, okay, can go up, can go left, can go down. Okay, but cannot go right. And also it can be rotate. Okay, so we do have this one reaction at F with a single direction, with a single reaction there. Okay, all right, easy, right? Any question before I proceed to the last one? No, eh? Okay, if no, let's proceed to the next one, the last one. FBD of the member ABG. Abang siapa ni? So you have to draw this thing only. Okay, you have to draw this member only. So draw it, excluding all the what do you call it? All the external body that we don't need it. Okay. So G, since we do have mass there, you have to put weight. Okay. You have to put weight. Okay. And then at point B here, you have to put the reaction, because it's roller. Okay. This body, this green color can go up, can go down, can go left, can rotate, but cannot go right. Okay. Okay. Because of the roller. So we do have reaction here. Okay. And the last one is at point A, which is the two reaction EX and AY. Okay, this is your FBD. Okay. I think we have to stop right now. Before we stop, maybe some question from you. Is there any question from you before I stop the class?
None from me, doctor. I feel like I already have a brain cramp.
Oh yeah, same goes to me. Brain cramp. Not only brain, but my body also cramp.
Tak ada, doktor.
Tak ada. Okay. So if no question, I think that's all for today. Okay. So this is not really tough yet, and not really tough yet. You have to be patient. There are many lecture that having after this. Okay. This is not really tough yet. Okay. All right. That's it for today. Thank you. See you 2 days later. 2 days. Yelah, 2 days on Wednesday, right? So thank you so very much. See you guys.
Thank you, doctor.
Thank you,
Stay
doctor.
Thank you,
safe.
doctor.
Thank you, doctor.
Masih ada lagi nih. Gita, Hosin Zing, Osama, Yusuf. Are you still with me in this WebEx? Nunadira Tanyui. Yeah.